Hello. Today I am going to discuss about phenol. Monohydroxy benzene is called as phenol. Monohydroxy benzene is called as phenol. Molecular formula for phenol is C6H5OH. Structural formula for phenol is this is the structural formula for phenol. One hydrogen atom for benzene is replaced by OH group. Then we can get phenol. The molecular formula is C6H5OH. Methyl phenol is called as cresol. There are three types of cresol. One is called as orthocresol. Then another is called as paracresol. Then next one is called as metacresol. There are three types of cresol. Methyl phenol is called as cresol. This is the formula for methyl phenol. This is called as orthocresol. Or according to IPC system, it is called as orthohydroxy toluene. This compound is called as metacresol or metahydroxy toluene. Metacresol. This compound is called as parahydroxy toluene or paracresol. These are substituted phenol. Let us consider methods of preparation of phenol. How to prepare phenol? First method of preparation of phenol. The aryl halide by Dawes process. When chlorobenzene is heated with 30% solution of sodium hydroxide at about 350 degrees Celsius temperature in presence of copper salt at 200 atm pressure to produce sodium phenate, which acidification gives phenol. Chlorobenzene means this is the formula for chlorobenzene. When chlorobenzene reacts with the sodium hydroxide solution in the presence of copper salt at 350 degrees Celsius temperature and 200 atm pressure, then we can get sodium phenoxide. This is the formula for sodium phenoxide, which acidification gives phenol. Acidification means addition of acid. That means when sodium phenate reacts with the hydrochloric acid gives phenol. OH plus NH. This is the formula for phenol. This process is called as DOS process. Second methods of preparation from sodium benzene sulfonate. When sodium benzene sulfonate is fused with the sodium hydroxide solution at the temperature 573 Kelvin to 673 Kelvin, sodium phenoxide is formed, which on acidification gives phenol. Acidification means addition of acid. When sodium phenate, this is the formula for benzene sulfonic acid. Benzene sulfonic acid when treated with the NaOH gives sodium benzene sulfonate. Sodium benzene sulfonate. OH gives like water. Then we can get sodium benzene sulfonate. Sodium benzene sulfonate when fused with excess sodium hydroxide solution gives rise at the temperature gives rise sodium benzene sulfonate, which are sodium benzene sulfonate when fused with sodium hydroxide solution gives sodium phenate. This is the formula for sodium phenate, which on acidification gives phenol. NaCl OH. This is the formula for phenol. When benzene sulfonic acid is treated with sodium hydroxide gives sodium phenate, that is a salt, which further fused with the excess sodium hydroxide solution. That means here we take 2 molecules of sodium hydroxide. Hydrogen atom of NaOH combines to OH gives water. Again, another sodium atom combines with the SO3 gives rise sodium sulfide Na2SO3. Then we can get sodium phenate, which are the acidification. Acidification means addition of hydrochloric acid, addition of acid. Then sodium atom combines with chlorine gives sodium chloride, and hydrogen atom combines with oxygen gives rise phenol. Let us consider third method of preparation of phenol from benzene diazinon chloride. When benzene diazinon chloride is heated with water in presence of dilute HCl gives phenol. That means aqueous solution of benzene diazinon chloride on a heating in presence of dilute hydrochloric acid gives rise phenol. Formula for benzene diazinon chloride. This is the formula for benzene diazonium chloride. When aqueous solution of benzene diazinon chloride is heated in presence of dilute HCl, gives rise phenol. Gives rise कौन? Phenol. Phenol plus HCl plus N2 gas. H2O can be written as HOH. H plus and combines with Cl mentioned gives HCl. N combines to N gives N2 gas. Then the OH group is attached to the rest part of the benzene diazinon chloride, gives rise phenol. This is the preparation of phenol from benzene diazinon chloride. When the benzene diazinon chloride, when aqueous solution of benzene diazinon chloride is warmed with dilute hydrochloric acid, gives rise phenol. Next method of preparation from cumene, isopropyl benzene is called as cumene. When cumene is oxidized with oxygen or air to produce cumene hydroperoxide in presence of a metal catalyst, it is then undergoes hydrolysis in presence of acid to produce phenol. That means how to prepare phenol from cumene. Isopropyl benzene is called as cumene. This is the formula for cumene. Here isopropyl group is attached to the benzene. This compound is called as isopropyl benzene, or in one word it is called as cumene. When cumene is oxidized with atmospheric air, in presence of metal catalyst, gives cumene hydroperoxide. This is the formula for cumene hydroperoxide. Metal catalyst CH3 CH3OOH. This is the formula for cumene hydroperoxide. You know that the formula for hydrogen peroxide is H2O2. Structurally it can be written as like this. By replacing hydrogen atom of hydrogen peroxide with the help of cumene, we can get cumene hydroperoxide. That is obtained due to the oxidation of cumene with atmospheric air in presence of a metal catalyst. This compound is called as cumene hydroperoxide. Which one hydrolysis, which undergoes hydrolysis in presence of acid gives rise phenol plus CH3CO CH3 acetone. Phenol. When cumene hydroperoxide undergoes hydrolysis, this part gives rise acetone. OH group combines with the benzene gives phenol. That means when cumene is oxidized with atmospheric air in presence of a metal catalyst gives cumene hydroperoxide, which on acidic hydrolysis gives phenol. These are some methods of preparation of phenol. Let us consider chemical properties of phenol. Chemical activity of phenol or reactivity of phenol is due to the presence of benzene ring and also due to the presence of OH group. That means phenol possesses reactivity due to the presence of OH group as well as benzene ring. Let us consider acidic properties of phenol. Acidic nature of phenol. That means here we consider acidic nature of phenol. Acidic nature of phenol can be explained by using concept of resonance. Phenol is a resonance hydride of following structures. Let us consider a resonance for phenol. This is the structural formula for phenol. Resonance means shifting of electrons from one part of a system to the another part. This is the formula for phenol, where oxygen atom contains 4 electrons. 2 electrons shifted into this position. As a result, a double bond is formed between oxygen and carbon, oxygen and carbon. Due to formation of a double bond, this carbon atom contains 5 bonds. That is why this bond can immediately shift into this position. Due to this carbon atom contains 2 electrons and also acquires a negative charge. Due to donation of electron, oxygen atom carry out positive charge. That means when electron shift from oxygen to carbon atom, we can get another structure of phenol, where oxygen atom acquires positive charge and carbon atom acquires negative charge. Again, this pair of electron is shifted into this position. As a result, a double bond is formed. Due to this carbon atom contains this carbon atom possesses pentavalency. To maintain the tetravalency of carbon atom, this bond immediately shifts into this carbon atom. As a result, we can get another structure of phenol. Again, this pair of electrons is shifted into this position and this bond is shifted into this position. As a result, we can get another structure of phenol. Where oxygen atom acquires positive charge and carbon atom acquires negative charge. These are the regenerative structures of phenol. That means by shifting electrons for phenol, we can write more number of structures for phenol where oxygen atom acquires positive charge and carbon atom acquires negative charge. The electronegativity value of oxygen atom is more than that of a carbon atom, and due to process of resonance, oxygen atom also acquires positive charge. As a result, the shared pair of electrons between hydrogen and oxygen is more attracted towards oxygen atom. Hence, a hydrogen atom can be easily released from the oxygen atom. You know that the substance which provides H+, that is called as acid. That means phenol is acidic in nature. Due to process of resonance, oxygen atom of phenol acquires a positive charge. As a result, the shared pair of electrons between hydrogen and oxygen is more shifted towards oxygen atom, so that the release of H+ becomes easier, which explains the acidic nature of phenol. It means phenol is acidic in nature. Between phenol and phenoxide is more stable than phenol. That is why phenol can easily give explosion to produce more stable phenoxide. Phenol easily give explosion to produce more stable phenoxide. Between phenol and phenoxide is more stable than phenol. That is why phenol can give explosion to produce more stable phenoxide. The stability of phenoxide can be explained by considering the concept of resonance. Let us consider the reaction of phenol with the metals and alkalis. That means we can also explain the acidity of phenol by considering a reaction of phenol with the active metals and also with the alkalis. When phenol reacts with the active metals like sodium or potassium, gives sodium phenate or potassium phenate with the H2 gas. That indicates the acidic nature of phenol. When phenol reacts with sodium or potassium metal, gives rise sodium phenate plus H2 gas. That means here hydrogen atom of phenol is replaced by sodium metal. If the substance is acidic, then it can provide H2 gas when it reacts with the active metals like sodium and potassium. Here also phenol reacts with the sodium metal to produce sodium phenate salt with the liberation of H2 gas. That indicates the acidic nature of phenol. Let us consider the reaction of phenol with the alkalis. That also explains the acidic nature of phenol. When phenol reacts with the sodium hydroxide solution, gives sodium phenate plus H2. Here NH is a water soluble base. It reacts with the phenol, gives rise salt and water. That indicates that this substance is acidic nature, as it provides salt when it reacts with the base. That means we can explain acidic nature of phenol by using concept of resonance, and also we can explain acidic nature of phenol by using following reactions like reaction with the active metals and reaction with the alkalis. Phenol provides H2 gas with the active metals, that indicates the acidic nature of phenol, and also phenol when it reacts with the water soluble base like NaOH, AOH, it also provides salt and water, that indicates the acidic nature of phenol. Phenol is much more acidic than alcohol because phenoxide is a resonance stabilized ion, but alkoxide ion is not stabilized by the process of resonance. That means when phenol gives H plus ion, as per its acidic nature, it produces phenoxide ion. Phenol gives H plus ion due to its acidic character. When it gives H plus ion to produce phenoxide ion, that is a resonance stabilized ion. That means the process of resonance is applicable on phenoxide ion. Due to process of resonance, we can write more number of structures for phenoxide ion. These are the residue structures of phenoxide ion. Let us consider the resonance for phenoxide ion. For phenoxide ion, we can write number of residue structures like this. These are the residue structures of phenoxide ion. From the concept of resonance and also from the characteristics of resonance, we know that greater the number of residue structures, greater is the stability of the compound. As phenoxide ion provides more number of residue structures, that is why phenoxide ion is a resonance stabilized ion. When alcohol gives H plus ion, this is the formula for alcohol. When alcohol gives H plus ion to produce alkoxide ion. Alkoxide ion is not a resonance stabilized ion. That means process of resonance is not possible in case of alkoxide ion. If we compare the stability of alcohol with that of alkoxide ion, alcohol is more stable than alkoxide ion. That is why alcohol does not give H plus ion to produce unstable alkoxide ion. But if we compare the stability of a phenol with that of a phenoxide ion is more stable than phenol. That is why phenol can easily give H plus ion to produce more stable phenoxide ion. Phenoxide ion is a resonance stabilized ion. For phenol we can write number of resonance structures. According to the characteristics of resonance, we know that greater the number of resonance structures, greater is the stability of the compound. That is why phenol is more acidic than alcohol, as it provides more stable phenoxide ion. In the coming class, we will discuss about the effect of substituents on the acidity of a phenol. Thank you.